Hi class. So just a little review for tomorrow's exam. The exam is going to cover all transformations. We have translation, reflection. We have questions about describing transformations. We did the composite functions. I'm gonna go over that in a bit. So rotations 90 clockwise, counterclockwise, reflection across these y or x axes. Basically did all this, right? And so the most important thing is I want you to show the work, right? So I want you to show me the coordinate points. So z is -4, 0. J is -5, -2. L is 0, -3. Okay. So the trick here is you're gonna have this on your in your sheet. These rules, these laws right over here on the side that I posted. So the trick is for rotation counterclockwise, you'll follow the rule -yx. So what this means is you're going to change, right, the position of the y and the x. You're going to leave whatever sign the x is, but you're going to change whatever the sign of the y is, okay? So z prime is going to be what? So remember, this is all xy, right? So we're changing it, right? So 0, -4. J prime is going to be, we're just changing the y, right? So 2, -5, right? And we're flipping it. And L prime is going to be 3, 0. So 0, -4, 1, 2, 3, 4. Okay, J is 2, -5. And then L is 3, 1, 2, 3, 0. Okay, so this is something what your shape should look like. Okay, so something like this. All right. And then what I want you to do is I want you to like put the name on it, right? So this is J prime and this is L prime. Oh, sorry, this is J prime. No, wait, sorry. This is Z prime. Okay, so Z prime, J prime, and then L prime. Yes, very good. Okay, so this is kind of how I want you to show the work. Now, in terms of translation, translation is nothing but putting. So I'm just gonna forget all this. So translation, you don't really need to look too much at the rules here. All you have to do is just follow along with what it's asking. If it's asking for 4 units right, yeah, we're going by the x, right? If it's asking 1 unit down, we're gonna minus by the y. So for example, if f is, so I'm just gonna give a coordinate. Okay, so if f is -1, 2, 3, 4, 5, 1, 2, 3, 4, right? So -5, 4. Okay, then what I want to do, since I'm going to the right 4 units, I'm going to add 4 by the x, and then 1 unit down, I'm gonna go minus by the y, right? So essentially what I'm doing here is I'm making a new coordinate point, -1, 3, and -1, 3 looks to be here, right? Oh, sorry, that's -1, 2, sorry. -1, 3 looks to be here, right? So that's your f prime. So now let's look at this. Let's see this, right? 1, 2, 3, 4, right? So we did 4 units to the right, so positive, and then 1 unit down, okay? And you're basically gonna do that for each one, but in order to not do that, I want to see this work right here. You can check yourself by this, but I don't want to see too much mess here, okay? I do not want to see mess. I want to see it done mathematically. I want to see the coordinate points, all right? So again, reflection across x, all you have to do is just count how far you are from the x, and that's how far you need to be below if you're above. Okay, that's how I think about it. Or you can use the rule, right? X -y. So you're just changing the sign of the y, right? So we're just changing the sign of the y. Okay, we're not changing the value, we're changing the sign. Okay, this is it. Okay, and then you're just gonna connect your dots. Ooh, that's not a dot. I mean, that's not a line. Okay, so you're just gonna connect your dots like this. And again, remember, right, with translation, the shape is conserved. Reflection, certainly the shape is also conserved, right? It's gonna be the same shape, okay? Rotation, still, the shape is, they're all conserved, okay? These are all conservative things. They're all gonna be conserved, so you don't have to worry about that. If something looks off, obviously that means you did it wrong, okay? Now, another thing is we talked a little bit about, let's see where it is. We talked a little bit about dilations, okay? So dilations, right? With dilations, it's very simple. All you have to do is you're going to multiply by the factor of what it's set, right? So each point, I want you to write it out, and then I want to see this math right here. I want you to multiply the x and the y, give me the new coordinate points, and voila, there you have it, right? So for our dilation, your shape will, of course, change. It'll be either bigger or smaller, right? So it just depends on the factor that you're dilating by, okay? So we did dilations, surely. There's a lot of, you guys can go back and review. Let's see what else we talked about. Okay, so we talked about composite transformation. So composite transformations. Composite transformations is nothing but having two or more, having two or more transformations that you need to do, right? So instead of doing just one, you'll do two, right? So on the exam, I actually give you enough space. So again, what I want you to do is I want you to, let's say, plot the points, right? And then I want you to plot the primes, and I want you to plot the double prime of it all, okay? So you'll do two transformations, and in each transformation, you'll give me the coordinates, and it's basically the same thing, okay? As long as you understand what rule to follow, where to follow it, how to follow it. Describing a transformation is very simple, right? This is our original triangle, okay? Prime means that's the first transformation, right? So the first transformation will be a reflection across the x, and then we have a translation to the second transformation, okay? So just as long as you understand this, you're looking at what you need to do, everything should be okay, all right? Now, in terms of congruencies and triangles, yes, we went over it. Maybe I'll put a few as I promised as extra credit, but these are very simple, right? So remember, 1, 2, 3, 1, 2, 3, okay? W congruent to G, V congruent to H, U congruent to I, all right? So that's how we do this, okay? So W is congruent to G, right? So W is G, V is with H, and then U is with I. Okay, so as long as you understand that, that's more than enough. Okay. In terms of, let's see, there's another worksheet that we did not too long ago. Oh yeah, so side angle, side angle. All this is just how to prove congruencies in triangles, right? So for example, in number 2, right? If we have, right, angle, side, and an angle, right? That is one of the postulates to prove, and that's enough to prove that these two triangles are, of course, congruent. Now, this shape is a type of parallelogram, right? And we talked about this, right? So when we get into quadrilaterals, we'll talk even more about this, right? So we're just cutting this parallelogram into two triangles, okay? And remember, this line will, of course, be congruent to itself, right? And these opposite angles will be congruent to the other set of opposite angles, okay? So then we can say angles, we can claim angle, side, angle, so angle, side, angle, right? So angle, side, angle is the postulate we will use to prove these two triangles of this whole parallelogram are congruent, right? let's look at let's say number 8, right? Let's look at number 8. So number 8, we have side, 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 right? So remember, the sides, of course, it all needs to match up, right? So we have one side and this side to be congruent, okay? We have this side and this side to be congruent, and this side is congruent. So yes, side, side, side is the way we're going to go with this, right? Same thing with number 10, right? It's a parallelogram. We cut it in half into two triangles. Remember, the shared side is always going to be congruent, just as the shared angle will always going to be congruent, right? Hence, here we have side, angle, side, right? And here we have side, 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 right? Because opposite sides will always be congruent, okay? In a parallelogram, in this type of shape, okay? So again, it's very easy. If you don't have enough, information, right? Because this is only what, side, angle, but you don't know anything else about these two triangles, so you say no, it's not, because I don't have enough information, right? And conversely, number 7, if it doesn't match up, right, as we talked about it in class, then no, it's not, okay? But again, these types of questions will be more towards the midterm, and then we're going to get into quadrilaterals. Like I said, we're going to do squares and rectangles and trapezoids, and again, we'll talk about parallelograms more, and I'll show you the rules and how we maybe we'll talk a little bit about proving them, like how do we prove them on a graph, by using, like, let's say distance, right, something like that. And then so it gets a little bit, it surely gets a little bit more involved, okay? But tomorrow's exam, primarily, we're just going to do transformations. Everything we've been doing, please just go over it. It's nothing too difficult. This should be a very simple exam. As long as you show me the work, everything should be fine. Okay, so good luck, everyone, and have a good night.